Section 2. Using the pyMongo module. In this section, we're going to take a look at the following. We'll look at how to install MongoDB, Anaconda, and pyMongo. These are the tools that we will use to teach ourselves how to use Python with MongoDB. In general, these are really good tools to know and to use in your data science pipelines, so they're well worth learning and having installed on your computer. We'll look at how to execute MongoDB queries in Python using the pyMongo module, as opposed to running our MongoDB queries directly in the Mongo shell, as we did in the previous section. We'll look in a lot more detail at pyMongo cursors. Cursors are the main way to retrieve multiple documents from a database after we've run a query using Python and pyMongo. We'll look at more complex retrieval of documents, such as when documents match only specified criteria. And then we'll work up to complex chained operations so we can combine filtering with aggregations and calculation of summary statistics from the documents in our MongoDB database. Setting up pyMongo. In this video, we're going to look at how we can install and verify our MongoDB, Anaconda, and pyMongo installations. I'll discuss very quickly the most common means to do so. Once we've made sure that you have your setup in order, so you can follow along with these worked examples, we will run some simple MongoDB queries using pyMongo in a Jupyter notebook. First message I want to impart is that I strongly recommend that you use the Python Anaconda installation if you're not already doing so. There are lots of different ways to install Python and Python packages. If you're using a Linux-based operating system, you'll probably already have a minimal Python installation installed. And the problem with using different Python installations and installing the packages that you need one by one is that you can get into a bit of a mess where you have several installations side by side and one package can be found by one installation and one cannot be. So the advantage of using the Anaconda installation is that you have pretty much all the packages that you're likely to need for plotting and data analysis all together in one place. The other advantage is the Anaconda installation comes with the Jupyter Notebook server. And if you're not familiar with the Jupyter Notebooks, this is a very nice environment for doing interactive data analysis. It's very rich, you can put all of your plots together in one place, and you can very easily share your analysis with other people, even if they're not coders. You could export it as a HTML page or a PDF, for example. So I would recommend that you go to anaconda.com/download and grab the installation that corresponds to your operating system. So while the Anaconda installation has a huge number of really useful modules, it actually doesn't include pyMongo by default. So you can read about pyMongo at this link, but really once you have the Anaconda installation installed, I would recommend that you just type conda install pyMongo, and that will use the Anaconda repository channels to install pyMongo and put it in the right place and make sure it's accessible to you. Finally, we need to have MongoDB, of course. We talked a little bit about this in the last section, but if you don't have that installed and up and running already, go to this link and you can see how to install MongoDB and set up the Mongo daemon mongod. Okay, so once you've had a chance to make sure all of those are installed, we'll come back and verify them. You can verify the Jupyter Notebook installation by typing Jupyter Notebook in a terminal, and that should open up a page showing you the Jupyter Notebook server in your default browser. Next, once you have pyMongo installed, you should be able to type import pyMongo into your notebook, and that should go ahead without any errors. And finally, you should be able to run mongod in the terminal, and that will set up the MongoDB daemon that will listen for any queries for connections to your databases. And if you have a problem with any of those, then I suggest you go back and try your installation again. Once you have all of that set up, return to the video and we'll run some queries through a notebook. Okay, so this is the notebook video 2.1, where we will go through some queries using pyMongo. First thing I'm going to do is import pyMongo, and that should go ahead without any errors. Quick tip I'm going to share with you, in case you don't already know it, is the very nice auto-completion feature of a Jupyter Notebook. So if I type pymongo dot and hit tab, it gives me this nice alphabetized list of all the ways I could complete that command. So these are all of the methods and constructors that come with the pymongo module. If I type V, it just gives me back all of the possible ways to complete it, beginning with V. If I execute pymongo.version, it tells me that I have pymongo version 3.4. And that information might come in useful if you find that your code differs slightly or the API that you're using is slightly different. Perhaps you're using a different version of pymongo to me. Now in this case, I am only really interested in the Mongo client object. So I'm going to install that, import that rather, from the pymongo namespace directly into my own namespace. Next, I'm going to create an instance of Mongo client called client. And another nice tip here, if you look at the constructor and I place my cursor just inside these brackets, if I hold down Shift and press Tab, then it gives me this helpful little pop-up that tells me about how I can, basically what's the contract for creating this Mongo client constructor, and it tells me about all of the options and arguments I can pass in here. If I want even more information, if I hit this caret, then I have this long, nice doc string which gives me lots of examples and discusses all the different options. So you're free to go ahead and explore the API in this way. I'll just say for now that here we're connecting to a database that is on my own computer, so it's hosted locally. And that's why I have this single argument localhost. If I wanted to replace that with an arbitrary URI, then I could connect to a database that's hosted somewhere else. And I can go ahead and also specify the port number and the username and password credentials. Once I have a client, I want to connect to a database. So in this case, I'm going to connect to a database called Pact. That database called Pact doesn't actually exist yet, but that doesn't matter. pyMongo will allow me to create that connection, and when it needs to, it will just create the empty database if it doesn't already exist. Once I have a database, I need a collection. And I'm going to create a collection called test collection, which also doesn't need to exist yet. Just as I did in the previous section by typing the query directly into the Mongo shell, here I'm going to insert a document into my test collection using insert_1. In this case, I am passing a single document with a key of A and a value of 1. Very simple test document. So a couple of things to note here. You'll see I'm just using the typical Python dictionary syntax, and that's converted into a JSON document and inserted. And this operation returns something to me. It returns an insert1 result. I'm not going to talk about that just yet, but just to note that this operation returns a value. Now I put something in my collection, I want to get something out. So I'm going to run find1. And that returns back the thing I just put in. I have the key and value of A1 here. And you'll also note I have this object ID. As we discussed in the last section, this is an index that MongoDB automatically adds to your document. So it's kind of like an indexing system. Now I put something into my test collection, I can ask how many things there are in total with .count. And that, of course, returns back 1. And I'll also add, if I put test collection dot and hit tab, I have this nice list of all the different operations that my test collection can do. And that's a nice way to explore the documentation. All right. Next, I'm going to insert another document with key B and value 2. And that goes ahead nicely, and it returns, I'm going to capture the output into this variable res, or result. and res has this property inserted ID, which is this pyMongo, or rather MongoDB object ID. If I then run find1 with the argument listed here of a key of b and a value of 2, this is basically saying find one, or find the first matching document in test collection that has a key of b and a value of 2. And of course this returns back the document I just put in is b2, and also we get this object ID, which is the same one that was returned as a result of the insertion. So you can see that these two things correspond. This first argument to find1 is called the query parameter. So this basically provides conditions for me to filter out documents that I'm interested in. This second parameter is called the projection operator. And that basically says, these are the fields that I want you to return, and these are the fields that I don't want you to return. In case there are some fields in there that I'm not particularly interested in, or some specific keys that I don't need. What we're going to do here is specify _ID as the key and a value of 0. And the value can be either 0 or 1, depending on whether I want that field or not. So if we do that, we can suppress the object ID here, and we just get back the raw data that we put in, B2. This might be useful if you don't really care about the object ID for now, you're just interested in that specific key. And note that find1 did not return this document with key A and value 1 as we got up here, because we specified these specific conditions which this first document didn't match, so it jumped to the first document that did match. Alright, now that we've created this database and collection, we need to clean up after ourselves. So let's go ahead and drop or delete this test collection. When I run db.drop_collection with the name of the collection as an argument, I get back this result saying that this was successful. If I try and do the same thing again, I get an error back, obviously because the collection doesn't exist anymore. Finally, I drop the database itself.